Okay, so here we go. All right, so number one, you were given the position time function of the thing. All right, so here's your function. Position as a function of time is t cubed minus 9t squared plus 24t minus 30. All right, and the question wanted you to find the average velocity. All right, so I saw 3 different methods for doing this. One of them is right. Okay, so first of all, let me talk about the 2 ways that people did it that are wrong, just to show you why they're wrong, so that if you had one of these methods, you can realize why it was wrong. And then I'll go back and show you the right way. Okay, so the most common thing I think I saw people do is they said, oh, I'm looking for average velocity. So let's find an expression for velocity. So you took the derivative. Cool. And then did one of 2 things. Some people tried to find the average velocity by using this guy. So they found the velocity after 0 seconds, the velocity after 3 seconds, and then averaged it, and then averaged it. Why doesn't that work? This equation only works if acceleration is constant. Okay? So that was issue number 1. All right? There were another handful of people that did this. They found the velocity after 3 seconds, the velocity after 0 seconds, and then did this. What's that the equation for? Acceleration. There are a whole bunch of people that found the average acceleration instead of the average velocity. Does that make sense? All right. So, if the acceleration is not constant, there is only one way to find average velocity, and that's by using the definition of average velocity. So what you needed to do was find the position after 3 seconds, the position after 0 seconds, final minus initial, and then divide it by the time. Does that make sense? Yep. Everybody good with that? Does anybody not understand if they got it wrong, why they lost points, why what they did didn't work? Okay. So this is huge, you guys. This comes up. There's another problem on the test that was the same thing. If the acceleration is not constant, the only way to find displacement is to find the displacement and divide it by the time. Cool? All right.
Wait.
Yeah.
Does that mean you can take the integral of velocity from a point to a point, and then, because that would be the displacement, and then divided by 3?
Sure. But what would the integral of velocity give you?
The change in
If you take the integral of this, it's going to give you this.
Yeah.
So you'd be working in a circle to do that. What you're talking about is what you had to do, I think, in the Pinkie Pie question. Cool. Sorry about the Pinkie Pie thing, by the way. Were you offended by the Pinkie Pie? I apologize. Was it the language, or was it just the Pinkie Pie? It was the Pinkie Pie. Okay. All right. Okay. Number 2, velocity at 2 seconds. Most people did okay with this. So for number 2, here's the expression for velocity as a function of time, right? By differentiating, plug in 2 seconds to get 0. Good? All right, number 3. I'll be honest, a lot of you, so it says, what's the thing's acceleration the first time he stops? And a lot of you looked above and said, oh, he stops after 2 seconds. But it didn't show me that was the first time he stops. And I didn't take points off of that, because I was already conscious of the fact that so was probably going to be low. All right? So, here's how you got to do that. Oops. Okay, so to do number 3, it says, what is the thing's acceleration the first time he stops? Well, the first thing we need to do is come up with an expression for acceleration as a function of time. I'm realizing that I told you to do corrections, and I'm doing them all right now, aren't I? Oh, well, but you got to still go through and do the calculations. All right, so find your expression for acceleration as a function of time. Good? All All right, now we got to figure out when he stops. So we need to find the time so that the velocity at that time is 0. So you got to set this thing equal to 0 and then solve. There are two answers. 2 and some other time. Okay? Some of you already know what it is because a few people actually did the math, but figure out those 2 times and then plug it in.
Wait, there were 2. Oh, but if it asks for the first time, then doesn't that mean?
How did you know that the first time could have been after 1 second? Sorry?
I put it in my question.
Oh, great. Okay, then tell me that. Yeah, so if you graphed it, great. But tell me that, because the graders are going to want to know how you found out that was the first time. Okay? Evan? It does factor. If you factor out of 3, it's actually pretty easy to factor. Yeah, Peter.
So sketching a graph would be good enough.
100%. And
Or
a couple
even
people
if you
did that.
said C, like put in a calculator.
Graphed on calculator, something like that, yeah. Cool? Any questions on 1 through 3? All right, Pinkie Pie. So incidentally, my wife bought me a poster of this for Father's Day last year, but it was all like pixelated and horrible looking, so I didn't hang it up. Okay, so Pinkie Pie has a velocity along an x-axis that follows an equation. So here's Pinkie Pie's velocity as a function of time. Okay, and you want the average velocity. So again, those same 2 mistakes. Some people found the velocity at 1 second, the velocity at 3 seconds, and averaged them. Some people found the velocity at 3 seconds, the velocity at 1 second, and then found the average acceleration. But that's not what we want to do. Okay. Is the acceleration here constant? No. And we know that because if you take a derivative, you're still going to have t in there, right? Okay? So, the only way that we can find v average is to find our displacement and divide it by the time. So, how can I use a velocity time function to find my displacement? Integrate, right? So our displacement is the integral between our 2 times, between 1 and 3 seconds, of v of t with respect to time. So that'll give you your displacement. Then you can find your average velocity. Well, I know that if I take the derivative of velocity, that'll get me acceleration. I want to go the other way.
Oh, plug into the v average equation.
Yep, because again, I can't say this with enough emphasis, or emphasis, however you prefer to say it. If you are trying to find average velocity and the acceleration is not constant, this is the only way to do it. Okay? Cool? So when I said there were some common mistakes, those 2 problems like there, that was 7 points. Do you know what I mean? So like, and now you know how to do that kind of problem, right? And I obviously didn't do a great job stressing it on the front end, but now we did it, and I think we're good, right? Cool? Is everybody happy? Anybody stewing? Anybody? Okay, cool. All right, number 5. A car has an initial velocity of 20 meters a second. It slows down with an acceleration given by negative 0.50 t. Is that a constant acceleration, you guys? No. Because it depends on time, right? Different values of time will give you different expressions or different values for acceleration. If it had been this, that's constant acceleration, right? Because if you take the derivative, you get negative 0.5. But that's not what it was. Okay? So here's my acceleration equation. It says, how far has it traveled by the time it stops? So I'm looking for my displacement when it stops. Do you guys agree that that's what I'm looking for? What is the displacement when it stops? So it's 2 steps. 1, we got to figure out when it stops. 2, we got to find the displacement in that amount of time. Follow? All right. This one actually people did pretty well on. The most common issue was just making little mistakes with integrals or not interpreting the plus c correctly. I'm sorry?
Never mind, I got it.
All right, so I'm trying to figure out how much I want to go through here because I do want you guys to have to do something on your own. Is this enough on this one? Does anybody want me to say more about this one? Yeah.
Yes.
Because you understood you were supposed to take the integral. So when I do that, when I write yes, no, it means this part's right, but then what you did with it is wrong. So this is correct, but it doesn't give you that answer.
I took the delta x. Took the 0. I plugged the 0 to me. Then I plugged in and then I
Oh wait, so this is no Oh, right. Yeah, this is the last. I got it. So after you get I don't know. Plug in the calculator. I think I know it's 0 is going to be 0. So really, you just put it in square root. All right. And if that doesn't work, we'll talk, Maggie, okay? I think you might have just missed the negative sign, or I don't know. All right. Does anybody want me to say more about pi? Have I said enough here to let you go? Jacob, how you feeling? Don't know where to go from here? Okay. All right. So let's talk through it. I'm not going to do it, but let's talk through it. Okay? So I'm trying to find the displacement when the velocity is 0. So do you have an idea for how to figure out when the velocity is 0?
Really screwed up this problem, so I have no idea.
Okay. So what do we know, Jacob? Like what's the given information?
The 2 things you wrote down.
Yeah, right. Sure, right. So we know this. That's telling me the velocity at one instant, and I know the acceleration. Right? But somehow I need to come up with an expression that tells me the velocity at a given time. Right? So how can I use these 2 pieces of information to find the velocity at a given time? In other words, what's the connection between acceleration and velocity? Yeah, take an integral, right? Definite or indefinite, you guys? Indefinite, right? Sebo, you had I can't remember, you came in after school and we came up with a good way to remember indefinite.
Instantaneous.
Indefinite gives you instantaneous. Indefinite, instantaneous.
What was the thing last year that one asked? Extender or
No,
It was both. All right. So if we integrate this, we can come up with an expression for the velocity, right? But it'll have that stupid plus c at the end. Follow? So then we can use this to figure out what the c is. Cool. So then you solve for 0. I think you end up with the square root of 80 or something like that.
Yeah.
Okay. I wanted that to work out nice. I made a mistake when I wrote the problem, so I apologize for the decimal. All right. So now we've got an expression for velocity, and to find displacement, now you do another integral. Does that help some? Yeah. All right. Are we good, you guys? Okay. Number 6. So 6 gave you a graph that looked like this. Okay, so the first thing I did was I found the area. I found the area under each of the chunks. Now, there were a few people that counted each box on the graph as 1. Okay, you can't do that. Okay, and then despite the fact that the graph is a little mixed up, like Teddy pointed out, most of the boxes were 10, right? And then I told you explicitly in class, I said, assume that this chunk here is 25. Okay, Sarah Ashtar, I'm going to pick on you for a second because I remember you picked, there was a point where you had to find the slope, I think, or something, and you did 20 seconds instead of 25.
Yeah.
And the only reason you got the wrong answer there is because the graph was jacked up. So I gave you credit because it was on me, not on you.
I think.
Okay. All right. All right. So anyway, so if you go through and find these areas, here's what you get. This one was 37.5. This one was 30. This one is 30. This one's negative 40. And then the last one, I don't remember. I don't think you need it. Okay. So question A says, what's the object's displacement between 35 and 95? And it's a velocity time graph. So what's the connection between velocity time graph and displacement? What do you got, Peter? Take the integral, right? Oh, but we don't have a function. So what is, when we take an integral, what are we really finding? Everybody, what are we finding? Area, right? So all you needed to do for number 6 was find this area, and then add them up. Okay? So most people have the right idea there, I think. Just, you know, just a couple little mistakes here. Area of a triangle is 1/2 base next height. Please don't forget the 1/2. All right, everybody good with 6? All right, 7. Show me 2 different ways of finding the average velocity during portion A. So here's portion A. 2 different ways of finding average velocity. So the first thing we can do is what we've been doing this whole time, right? V average equals displacement over time, right? So my displacement is the 37.5. The time was given to you, so divide. Okay. Now there's one other way to do it. What do you got? Sure. Go ahead.
Can you predict the velocity at 1.5
Yes, you can. That's the same as doing something else. So hold that thought for 1 second. What do you got, Justin?
Velocity final plus velocity initial divided by 2 because acceleration is constant.
Oh, say that last part again.
You can only do this because acceleration is constant.
How do you know, based on the graph, how do you know the acceleration is constant?
Because it is linear on the velocity over time.
The slope is constant. That means the acceleration is constant. So this is the only problem on the test where it was okay to use this equation. Cool? Finally, this equation is VF plus VI. A ton of people have VF minus VI. Okay, because you're literally taking an average. Okay? And Peter, to what you said, doing this is the exact same thing as finding the velocity halfway through.
Yeah.
Because it's linear. All right, everybody good with 7? Good? All right, number 8 wants the acceleration over here. Well, the acceleration here is constant. So what do? Just find the slope. Slope is rise over run. There are like 5 people who did run over rise. Okay? Rise over run. So your rise is -2, your run is 40, divide it out. Give me your answer as a decimal, not a fraction, please. Okay? Sorry? 3, I don't care,
Okay.
but 3. All right, everybody good? All right, number 9. All right, so here we go. We got a bucket. The bucket's moving down at 6 meters a second, and at that instant, a nail falls out and falls down to the ground. It's going to fall down 8 meters. And the question wants to know how long it takes to hit the ground. All right? Now, the bucket is moving down at 6 meters a second, but the problem is about the nail. So what does the 6 meters a second have to do with the nail? Yeah, if the bucket's moving down at 6 meters a second, then the nails are moving down at 6 meters a second. So when it falls out, the nail's already got that initial velocity. So here's what I know. My initial velocity is -6 meters a second. Right? What does the 8 meters represent? Displacement. What do I need to do with it? Negative, because it's going to go down 8 meters. I know one other thing and only one other thing. Acceleration is -9.8 meters a second squared. We are looking for time. Is the final velocity 0? No. A lot of people made the final velocity 0 thinking, oh, it hits the ground and stops. No, I want to know not how fast the final velocity doesn't represent how fast it's moving after it hits the ground. It represents how fast it's moving as it hits the ground. Follow? All right. Finally, when you if you find your final velocity to solve this, that's cool. To find that final velocity, you got to take a square root. What's the square root of 9, you guys? Plus or minus 3. So when you take that square root, you need to, I think it gives you like 13 or something like that. You got to then decide, is it positive or negative 13? And it's negative, right? Follow? All right, questions on that one? All right, I think that, yeah, okay, cool? All right, now, the dreaded last page. Okay, how can I explain this most easily? All right, so first of all, this is a common type of problem. All right? Sarah's giving me middle fingers with her eyes right now. All right, 4 of them, weirdly. I don't know how she did it, but all right. So problems are often presented this way, where you're given information about a thing happening, and you're told, for example, how high the thing goes, but you're not given a number, you're just given the letter H. Okay? And you're not told how long it's in the air, you just said it's in the air for an amount of time equal to t. Okay? So, all right, so here's the deal. Here's your given object. Okay, let's call that object A. All right, so it says an object is launched straight up into the air from the surface of the Earth with some initial velocity v0, so that it rises up to some height h. So v0 and h are both numbers. We just don't know what they are, but they have a fixed value. Okay? Before falling back to the ground after being in the air for a total time of t. Answer the questions in terms of the variables. So here's my drawing. So here's my object. It's going to go up, it's going to come down. I know that it's fired with a velocity of 0. I know up at the top that my displacement is h. And I know over here my time is t. That's a dumb thing that I just wrote, but it's accurate. And my velocity here is negative v0, right? I also know at the top that my velocity is 0. Cool?
Yep.
The one other thing I guess I know is I know my acceleration is g, right? Or ag, however you want to think of it. All right, good? Yes, Sarah.
Why is D equal to negative V0?
The path is always symmetrical, so if you shoot something up with some velocity, it loses all of that velocity on the way up. On the way back down, it gains that same amount of velocity.
So that's the point at the bottom.
Yeah, that was meant to be at this little dot here.
Wait,
Cool?
Thank you.
Yeah, no, I'm sorry if that wasn't clear. Margaret and then Teddy.
so theoretically, if you wanted to like the cap up and the cap down, that's just 65 by 2.
Yep. Teddy.
A equals 3.
Who, what?
A equals 3.
This is given out.
This is the.
This is the given one.
Oh, like it's isn't that true? Yeah, that's where.
That's why I'm saying that I think people were confused. It's worded badly. So I'm trying to walk you through what I was going for. I haven't even gotten to A yet, Teddy. Like, do you see what I mean? It says, suppose an object is, like, read that paragraph. So this is a drawing of that paragraph. Good? Is everybody good?
Yep.
All right. Now, it says in part A, it says, suppose the same object is launched again at the same velocity, but now we're on a new planet where the acceleration of gravity is no longer g, it's 3g. Okay? So here we go, part lowercase letter a. So we're going to launch it with the same velocity. It's going to go up and come down, but now my acceleration isn't g anymore, it's 3g.
I didn't know that's what it was.
I know, I get it. So, but does that make sense, you guys? So now I want to know, based on those circumstances, how long is it going to be in the air? Good? Teddy, are you good? Are you lying so I'll leave you alone? Okay. Fair enough. Okay. So over all right, so over here, how would let's see if we can write an expression over here for the time that this thing is in the air. So let me smallify my drawing over here. Okay, so over here, the time that this thing is going to be in the air for, how would we figure it out given this information? To me, the easiest way would be to look at the change in velocity and divide it by the acceleration, right? So my final velocity is negative v naught. My starting velocity was positive v naught, divided by g, right? So that's negative 2 v naught over g, right? Is negative v naught minus v naught. Follow? All right, so let me pause there for a minute. So that's what t is. Everybody good? All right, so now the question is, what will my new t be if I replace g with 3g? Isn't it just a third of t? That's the answer.
Oh, no way.
Right? If you've got 3 times as much gravitational pull, it's only going to be in the air for a third as long, right? Because the velocity is going to decrease 3 times faster. Okay, so I'm hearing a lot of O's. I think that those O's are, I didn't realize that's what you were asking for. I get it. I'm sorry. I'm sorry. Again, you guys, it's just my second time teaching, and I'll try to make sure that I write the problems more carefully.
This problem wasn't really hard, but it was just hard. I was expecting just to
I will say, real quick, if this helps any, never mind, that won't help, because it'll sound like I'm being defensive. So,
I looked at the AP sheet, and it said that, it said that something about final velocity equals initial velocity
Plus AT. Yeah, that's the one
That's
I
the
used
one I
too.
used, and I got it wrong.
Yeah.
say that one more time. The AP sheet you used what?
The AP sheet said that EF equals EF plus AT.
Yeah, that's the same as this. Rearrange
I
it
got
for.
the wrong answer.
Oh,
Something.
what did you use for your VF and your VI?
Okay. The VF I said was 0.
Okay.
And you use time as well.
So there's your problem. That's half your time. So were you one of the people that had 2/3 T?
I decided just to look at the
Gotcha. Gotcha.
I didn't know it was really so much.
Okay. So does it make sense? Okay. Cam, what do you got?
I did look back and so then I found like a time I was like, oh, that's multiplied by 2, but I got 2/3.
I have to no. It should be 1/3 T because you'd have to double it at both ends, so those 2's should cancel out on both sides. Do you know what I mean? Okay. All right. So here's this, you guys, and I've since gone back and rewritten this problem. I think I'm going to put this problem on a homework assignment next year, but reworded better. All right. And the way that I reworded it was like question, and I think this is why Teddy's pissed off. And I get it. Question A1 says, how long would the object be in the air? I wrote, in terms of t, how long would the object be in the air?
Yeah, that's
And for Roman numeral 2, it says, in terms of h, how high would it go? Etc. Okay? So, if you want to jot that down, we did A Roman numeral 1. Roman numeral 2, I want you to answer in terms of h. For B, Roman numeral 1, answer in terms of t. Roman numeral 2, answer in terms of h. And C, you answer in terms of V naught, because you're trying to find the velocity that has to be launched at. Good? Okay. Can I leave it at that and let you guys think about this a little bit over the weekend?
sure.
Good? We'll talk next week. Next week's a weird schedule because of homecoming and that kind of garbage. I don't know if I can give up. The only thing is I'm not sure I can give up another class period for it.
I will come in the morning.
So that's what I was thinking. Is I was thinking maybe I'll give you like a 2-day window or something and say you got to come in before or after school or during a tutorial during one of these 2 days. Something like that, kind of like what Tyson does.
Oh yeah, those were always fun.
Okay. Yeah, Daniel.
So just 2 quick notes. Thursday is our spirit day, so that's probably a bad day. And
Okay.
Friday is unity day, so that's also a bad day.
Okay, so maybe we do Tuesday or Wednesday.
Monday morning.
We can skip some rounds. Okay.
But I need time to rewrite. I gotta write a new test now, so. All right, yeah.
When we retake the test, will we be able to get like full credit, or are you gonna be like?
If you retake it, new score counts.
Okay,
So
so
if you get 100% on the new test, then you have 100%.
And 0.
If you get a 0, then you get a 0. Don't do worse. 7. I'm gonna grade it. That's Leo.
Crush it though. I mean, it's better than 27. Yeah.
You won't do worse. You won't.
Yes.
Absolutely.
That's quitter.
watch.
That's right. Okay. You good?
Do we have to take the whole test?
I will talk. If you have concerns about that, I'll talk to you on a case-by-case basis. Most people, yes. There are a couple exceptions, though. I think. Joe. Same thing. Same thing. Okay. Peter. And then.
Let's say I'm crazily overcommitted for homecoming. Can I come in during like my tutorial to take this?
Yeah, totally. Yeah. Yeah, we'll work it out one way or another. I don't want to put anybody at a disadvantage. We'll figure it out. Sarah.
Well, if you similar types of problems on those things,
I mean, they're not going to be, it's not like I'm going to just go through and change the numbers. But, there will be problems where you got to do integrals, where you got to take derivatives, and there will be a graph problem, and there will be a problem like this with no numbers.
Is the graph gonna be correct next time?
The graph will be correct next time, I'm sorry. I stole that off the internet, and shouldn't have done that. Okay, are we good? Alright, so, for what it's worth, you guys may remember last year, our first test in honors, we had a similar thing, and then I think things got better from there
Oh
on
yeah, the
out.
one that was meant for like an hour and a half.
Yep, so we'll figure it out, you guys, alright? I apologize, I know this is a drag. Adam? Is that reasonable? Okay, so yeah, so over the weekend, go back and fix stuff. I'll trust that you're going to do it. If you've got questions, let me know. Yep, take these home, keep them, do what you got to do.
Oh my gosh, dude, he's so
Good? Yeah, right? Alright. Oh, hey guys, last thing. When you come in for your retest, I will forget to ask you, because I'm stupid, you need to give me your original test, so I can staple your original test to your new test. Okay? Clear? Okay.
Wait, so when we do make the corrections, is that only for...
It's for your benefit, yeah. Hey, you good?
Are we getting our tests like to keep, or you can just keep it?
I haven't decided yet. I think by next year I know the material well enough that I can write a new test every year. I'd love to let you guys keep your tests. It'll help you prepare for the AP test so much better. The exception might be once I start getting to old practice tests. That might be the exception. Yeah, I had that same system last year and nobody ever did it. I don't know. We'll figure it out. We'll figure it out. Yeah.
Is there anywhere that we can find additional supercard effect from AP?
Yeah, sorry. At this point, I don't have enough resources to say, yeah, I have this sheet. The book has tons of stuff. Alright, so, the bell rings here in like, 10 minutes, okay. Is it 45?
Yeah.
Oh, and announcements.
Can you watch the announcement?
Alright. Okay, shoot, so we're behind then. Alright, so Monday we are going to hit the ground running. This chapter is, the next chapter we're going to do is vectors and two-dimensional motion. Alright? I don't think it'll be bad. That said, I remember last year we really jammed projectiles in and you guys struggled with them. So I'll make sure we spend more time on that. Okay? I think you'll be okay. Well, but I said that on this test too, so who knows? Alright, alright.